Bandwidth for this podcast is brought to you by Ideate Software. Be sure to check out all of their great Revit applications designed to increase your productivity.
I'm going to start introducing Ian Siegal, who used to be in BIMThoughts. He's still there if you want to go find it. Dana's taken up that throne with her new YouTube channel that has 1,000 subscribers already. Yay, you did it. Now we just need those 4,000 hours. So I want everyone who's listening to this podcast to go to Dana's YouTube channel and just play it in the background. Don't even worry about it. That way she get her 4,000 hours. So Ian,
perfect.
What the heck have you been up to? I think you need to redefine yourself and tell everybody in the world who the heck you are and what you do now.
Redefine myself. Sure. I love the technical way that you guys asked that question on the show.
Do you?
I'll give you a technical answer too. I'll sort the order of my response and what's probably most relevant to our conversation. I'll get less and less relevant as I go. So most relevant. So lately I've been with a really exciting prop tech company called Willow. Willow develops digital twins of buildings and infrastructure, and I've been a digital project director with them. So been working really closely with a lot of really exciting and major
So I guess prop
owners.
tech would be property tech.
Yeah, that's correct.
So
Yeah,
smart. So
great
smart.
question. Yep. Dana's
Ding,
got
ding,
it.
ding, ding, ding.
Prop tech, it's like real estate technology,
Prop tech.
property technology. Yeah, exactly.
Yes.
Exactly. And so that's been a bit of a departure from where I started my career, which was in the BIM management and VDC space, working with KPF architects. So lately I've been I say lately, it's been like 4.5 years or something I've been with Willow.
In a row.
In a row, consecutive.
Yeah. Mm-hmm.
And it's really been an exciting kind of trajectory into a space that I probably 4.5-5 years ago wouldn't have expected my career to take that turn. And it's been really interesting to see the value that comes out of like the design and construction process, especially when it comes to things like BIM and VDC and asset data collection. A lot of the things that probably a lot of listeners on the show spend their time doing. But once it makes it over the fence into the owner's world and they're operating the facilities and operating the assets, the way that they interact with that data has been really interesting for me to see. And I'm happy to expand on that during the conversation today.
Absolutely, because I think we all want to know what the heck happens to our little baby models once they grow up and become into the owner's hand. Do they just go away? Do they get used? Do they get cursed at? What happens?
More often than not, they probably just kind of sit on a file server and collect digital dust.
Digital dust, yeah.
Right? How does a Revit model get dusty?
Yeah.
So they certainly get turned over at the end of construction. Sometimes the owner kind of they'll file it away, and if there is a renovation or some sort of alteration that they want to make to the building, they might provide that to the next architect, the next engineers, next contractor for their use. There are certainly a handful of BIM for FM platforms out there that also tend to make use of that data, but that's really just kind of starting to gain traction. One of the interesting things that I learned working with a handful of these owners, they tend to try out the BIM platforms, and especially recently, a lot of these platforms are starting to call themselves digital twin platforms. That's the new buzzword. But to be totally straightforward, the feedback that I tend to hear from a lot of owners is that, like, yeah, BIM just isn't all that useful for us. We don't need a 3D model to operate our facility. Our FMs know the building like the back of their hand. They don't need a model to tell them where they need to go walk to a piece of equipment. They know where stuff is. So what's been really interesting to learn from the owner and operator world is that a lot of the data that's within these models certainly can be useful, especially if they have a way of easily navigating to it. But a true digital twin maps out and makes use of all of the relationships between things like pieces of equipment, and spaces in a building or devices and the broader systems that they're a part of. Owners and operators are also very, very concerned about things like who's in their buildings, or like what's the relationship maybe between, let's say we turn off a circuit breaker. What are the pieces of equipment that are also going to turn off? Which certainly can exist in a Revit model if it's built the right way, but extending that functionality to, okay, well, if this air handling unit or this piece of equipment is turned off because I flipped that breaker switch, what are the tenant suites that are served by that piece of equipment? And who are the tenants who take space there? Am I going to upset one of my biggest tenants who's up to renew their lease in a year or 2 years? And I want to make sure that we're treating them as well as we can, or is this work that we do after hours? So being able to interact with a lot of the data that we work with on a day-to-day basis, but through the lens of an owner and operator is something that I've personally found fascinating. And I think a lot of architects and engineers and contractors don't really get the chance to see that type of data in action because it's so new among the owners.
Yeah, it seems like we all walk the walk or talk the talk of the BIM model is great. You can use it to do all these other things, but I don't know if we really took the time to see if the owner really does use it or how the owner can use it. Is the model that we're creating useful? I mean, it's useful for building the building, but is that stuff really needed? All that data that we have in there really needed after the fact? Maybe it is for renovations. If we want to renovate the building, add additions and things like that, we'll want to know where all of those connections are. But I can see your point of view where day to day doesn't really matter where that column is. It matters where that duct goes or where you bought that piece of, well, not even where you bought that piece of equipment, because that's not going to be stored in the model.
Well, and I think I think this would be a perfect place for us to say, let's see it, right? Like definitely want to see what this is all capable of. But it's interesting to see the flip side of the coin. I think it's almost just as interesting as like going from architecture or engineering, like the design side of things, to construction, as it is to go to the development or real estate side of things, and to see in actuality, we always have these ideas of what's happening on the other side of the fence, but to see in actuality, this is what's going on or not. And I think a lot of the time when we have those conversations with clients and owners, those types of conversations are usually disheartening because of the cost involved in changing over your system so that it incorporates BIM in some way or any kind of data, right? Like, I think it's really interesting and enlightening to see that, these types of things not only exist, but they're in use.
Well, I think another good point from stealing from Dana and from Ian, a lot of the times it always does come down to cost, especially on the owner side. And I think more and more it's that perceived cost, what they think it's going to cost. And it's always hard to show the value or the return on investment of what you can save from something that's not going to happen. How do you put a value on something that's not going to happen and sell it to somebody? So I think that's one thing that one of those hurdles we have to tackle. The other thing is from what Ian was saying, and the idea that owners need you to map that, and the very strategic word of using the map, meaning that it doesn't all have to be visual. When it comes to the idea that I need to know which pieces of equipment are affected when I turn off that breaker, I don't need to see them. They don't need to light up inside of the model. I mean, maybe that would be cool, but just knowing that if I flip that switch, room 3, 5, and 7 go down, that's game changing, because we all know, we've all worked in that building that's 20, 30, 50 years old, and it's had a tenant fit up 17 times, and the AC goes off downstairs, and all of a sudden your bathroom's 1,000 degrees and nobody knows why, and nobody can find that switch. So having the forethought to think of that ahead of time, I think is going to be a big like, game changer. And again, we don't need to see that visually, but we need to know that information, have one spot to get it. And I think
and I think it's most likely the other way. It's that bathroom down the hallway is very hot. Why? As opposed to, is it going to affect that bathroom when I turn off this AC unit?
Well, exactly. Yeah. Because you get you get that conversation from the end user. So you may not see a blinking light right away. You get that call from the user. So then I have to track back from that bathroom to where that breaker switch was exactly.
Absolutely.
Point, Bill.
One of the other and definitely related fascinating things that I've learned from working on the owner side for the past couple of years is that there's an entirely different technology stack that owners and operators tend to use that this is no fault to architects and engineers and contractors, but we just kind of don't really need to be privy to or understand. Like one solution in particular, one actually, let me start before I go to like the other technology that they use. Like just the building management system. This is something that like a lot of us have maybe a very high level understanding of what it does. It's basically you can almost think of it as like the control system behind the heating and cooling system in a building, right? So if there's a thermostat reading in a room that says it's exceeded, I don't know, maybe the set point is 72 degrees and it gets to be 73 degrees. That thermostat reports back to the central brain of the BMS, the building management system, and it knows, all right, this temperature has been exceeded. This is the air handling unit that needs to start serving cooler air into the building. Maybe even further upstream, this chiller needs to go into a different operation mode. So all the stuff in the background that we kind of take for granted when we're sitting in a room and it's comfortable, the BMS is orchestrating all the different things that need to happen to deliver conditioned air into a space. And of course, there's highly complex mechanical and electrical systems that all work together to make that happen. But that BMS is a central part of the day-to-day operations of the building, especially in a commercial office building where you've got like Class A office tenants spending thousands and thousands of dollars per square foot to take a space in that building. So that's just one thing that I think architects tend not to think about. Engineers think about a little bit, especially controls engineers who need to design these systems, and then specialty contractors like Schneider Electric and Siemens and Honeywell that go in and manufacture and install the systems. But what's kind of interesting is that there are a whole bunch of other technology solutions on the market that appeal to owners and operators of these buildings that make use of all of the data that comes out of a BMS. Because if you think about it, that is a history of when are fans spinning, when are like dampers in the ductwork, when are they open and closed, and what's the impact that it's having on the temperature readings. Sometimes there's even electrical metering systems that are part of this system as well. So there are solutions out there that do nothing but take all of this data out of the BMS, so the history of operating a building, and they run analytics on it, and they generate what are called faults. These types of solutions are usually called fault detection and diagnostics solutions because they detect issues and propose ways of doing things like if you make a minor adjustment to the way you operate this piece of equipment or this system, maybe you can reduce the amount of energy you consume over time, or maybe you can prolong the useful life of the equipment or the system if you make this subtle tweak to the way you're operating the system. And so that's something that like architects and contractors tend not to think about very much because we're more interested in making sure that we're specifying the equipment that's sized the right way. We're making sure that it's being put in a place where it gets everything it needs to operate. But this is a wealth of very granular data about how the building actually performs after it's commissioned and operational. And these types of solutions need to get that data into their cloud environment before they can start running analytics and feeding it back to the operations teams. So that was like an entire side of the industry I wasn't even aware existed. And it's actually one of the areas where the digital twin makes a lot of sense. It's like when we think about digital twins, we're usually thinking about, okay, it's a 3D model of the building. It's like, but the digital twin that owners are interested in, sure, they want to have a really great 3D visualization of their building just because it's a really attractive way to navigate the space that they're managing. It's like, but the data that's most valuable to them uses the BIM as an overlay, certainly uses the metadata that we gather from design and construction, like who was the manufacturer of this piece of equipment, what's the model number, what date was it installed, what electrical circuit breaker is feeding it power. It's like, but there's actually quite a bit of live data systems that are smart in and of their own right, like the BMS and electrical metering systems, like elevator control systems, lighting control systems, all of those different systems that go into a contemporary building. Any building that's 10 years old or less likely has all or most of those types of systems. And they generate a tremendous amount of data about how the building is actually used. Those are the types of data feeds that owners and operators are really interested in being able to, one, bring into a single environment so they can navigate it within the context of their space. But they also want to be able to serve out just the right, I'll say, segments of that data to these other solutions that they're interested in kind of bringing into the mix so that they can optimize the way that they're running their buildings. And kind of get the results back. So that's one of the ways that the digital twin solution is really creating a tremendous amount of benefit. And there are certainly inputs that come from the design and construction supply chain that help enable that and help visualize that data for the long term, for the life cycle.
It sounds to me like the digital twin really isn't a twin.
How's
it's
that?
more of, well, the BMS system is going to need different kinds of data than what the Revit system has or what some other system may have. It may be the same kinds of data like square footage of this area where it's going and things like that, but it's not going to have all of the same data in it. It's not really a twin. It's more of a subset of what that original model was.
The sibling.
And yeah, a sibling. Yeah. And so that was one of the things I gathered from that conversation. The other one that gathered was it would be interesting, like thinking about the data that collects about the temperature. Do they look at it and go, okay, we know we turn off the air conditioners on the weekend to save electricity, but when is the optimum time to turn them back on in order to get the temperature back to normal by Monday morning? Do we turn it on at 3 a.m.? Do we turn it on, can we turn it on at 5 a.m. in order to save the most amount of electricity, but still get the same results? So those are some things that I thought about while you were discussing that, but haven't thought about before.
Mm-hmm. Yeah. So the short answer is yes. Like, that's actually another subset of technology. And there's some really great vendors out there who build technology solutions that do nothing but that. And they do it extremely well. They analyze the data and they start to suggest those types of things. Like, instead of starting the building up at 6 a.m. to make sure that everything is cooled off by 8:30 when your tenants are largely in the office, you can probably start the building up at a different time and conserve energy.
Right.
What really starts to get interesting, though, and this is where the digital twin, where like I usually start these conversations and say, like, if you were to ask 10 different people what a digital twin is, you're going to get 10 different answers, just because it's still a brand new term. And everyone, depending on where you are in the industry, you kind of tend to take your purview of like your responsibilities as an architect. An architect might have a different view of what a twin is than a contractor, and certainly an owner would, or an asset manager would have their own views about what a digital twin can do for them. But one of the things that we basically are seeing is that, like, what a digital twin needs to be able to do extremely well is take all of these different data sources, and I'll use the term normalize them. It's a very technical term that maybe a lot of the listeners on the show would understand. But like, whenever you have two different data sets, if they're related in any way, but not yet kind of keyed up, one of the things that you need to do is normalize the data. Meaning, if you've got like a list of 10 things in Excel sheet number A, and then you've got, I don't know, a different Excel spreadsheet, but they're describing different things about the same 10 things that you described in that first sheet, being able to link Excel sheet B relates to Excel sheet A in this way. Like, being able to map and build out the relationship that now makes these two different data sets make sense, linking up those two different fields. So what the digital twin needs to be capable of is taking all of these different data sources and normalizing the data and getting it to make sense in context with one another. Because Bill, you're absolutely right. A BMS, when you look at it, for the most part, is just like, it's trend logs. It's like line graphs. And each different line or each different data point usually ties back to a piece of equipment that's likely in your Revit model. But nobody has taken the time to say, this temperature, this static pressure, this, I don't know, fan speed, these three BMS data points correlate to this Revit 3D model element. Here's its GUID and Navisworks, and it's a 3D model of an AC unit on the 42nd floor of this office building.
Right.
So part of assembling a digital twin is taking all these different data sources that are useful to usually different audiences or different scenarios and bringing it all together so that you can very easily navigate to a piece of equipment or a system or a floor and have right at your fingertips all the data that's relevant to that thing. And the way that we do that is we worked on, this is the way that Willow tackled this solution, is we actually partnered with Microsoft to develop an ontology. So basically a data framework that works for buildings and infrastructure and is standardized. So basically there is now a definition for, if this is an air handling unit, these are the parameters that you tend to look for. It's customizable. You could expand it out project by project or customer by customer. It's like, but now we've got that working within the Microsoft Azure data model, and we can very easily start to pull different Azure services that are really good at handling things like real-time information for from BMS trend logs, for example, and put that into context with like the O&M manual for that piece of equipment. And then we can pull up the 3D visualization. We could serve all that data up because it's all related, even though it's coming from different places, and have it all in a single place.
Very cool. So I can see, yes, having those relationships to the other data. It's like you need a data management solution as well. Something that can talk to all of those different systems as sort of a single pane of glass. Like we've all heard that in our IT world. And without having those relationships, you can't talk to the building management system. You can't talk to the system that brings up the specifications on that air handler unit or the other things. Yeah, I can see that.
You got it. And the kind of the name of the game for us has been, how do we not just build a custom digital twin for every single building, right? Because no two buildings are exactly identical. Even if there are two buildings that are very similar, how do we make sure that we're not kind of building a digital twin from scratch every time that we go in and start a new project? Like, our objective is to make the platform that we use to assemble digital twins easy enough that an architect or an engineer or contractor, commissioning agent, a BMS vendor, systems integrator, all these different members of like the building industry are able to take the software and start to perform those integrations and hook up their respective systems into a digital twin at scale. So that way we're not doing custom software development for every single building. That's usually, whenever you hear about these single pane of glass solutions, that's usually what they are. Each one is built maybe from a template, but it's largely a custom software development exercise to integrate to the BMS, integrate to lighting control, integrate to whatever systems.
And God forbid, integrate to your Crestron units.
I don't know how easy or hard those are to integrate to, but based on my experience using them, it doesn't seem like it's no, it doesn't seem straightforward.
Not at all. Not at all. Dana, you've got something. I know you've got a question.
I want to see it.
All right.
Cool. I'll go ahead and share my screen.
Okay.
Share away. And for those of you that are listening to this enthralling discussion about BMSs and digital twins and maybe their digital siblings, if you haven't had a chance to head on over to our YouTube channel, this is where you can follow along with the demonstration that we're about to see here. So finish listening, park your car, go into the office, open up your laptop, and watch what we're about to see. Ian, the floor is yours.
Excellent, thanks. I think I just started sharing my screen. Everyone able to see?
Sure did.
We can see it.
Terrific. So what I'm showing right now, before we jump into the platform itself, this is one of the easiest ways that I find gets people with different backgrounds or different roles in the building industry on the same page about what a digital twin is. When Willow defines a digital twin, we're talking about a precise and a virtual replica of how a real building operates and works in real time. And there's a couple of different I'll say data streams or sources of information that tend to contribute to a digital twin. The ones that, these are also like certainly very high level terms. If you guys have questions or want to kind of drill deeper into these, we certainly can. But the broad terminology that we tend to use for these different types of data, one of them we refer to as spatial data. So if you think about a 3D model or a Revit model of a building, that's usually what we're referring to as spatial data. This is a representation, a geometric representation of the building, of its spaces, of the equipment and devices and systems within it. So this is basically the way that you represent the building, its components, and its spaces. So it's a graphical representation of the building. And we refer to that as spatial data. The next one down is asset data. Now, this is, you could think about asset data as like a database of information about the equipment and devices and all the components we just talked about. So attributes like manufacturer, model numbers, serial numbers. This, of course, can be customized based on the type of equipment as well. So, for example, air handling units are going to have a certain capacity in cubic feet per minute, I think, CFM. Yeah, cubic feet per minute. Pumps will have like how many gallons are pumped per minute. So that asset data information is a series of attributes and metadata about each different piece of equipment. Some of that might exist in a Revit model or a Navisworks model or a building information model. So we could certainly source asset information directly from a BIM. Other times that we'll get this asset data just through Excel from the design team or construction team, or in the case of an existing building, we could get it directly from the owner and their facilities management team in Excel format. So asset data is really just information about the building. And this could also be things like O&M manuals and attachments or photographs of the equipment. So think of this as like an asset information database, all the metadata that goes into it. And then the third one down here, we'll stop at that before we kind of go any further. But the third one down is live data. So this is like what we talked about a couple of minutes back, integrations into systems that are monitoring and reporting large amounts of information about how the building is actually performing. These might be systems like the building management system or the BMS, lighting control systems, access control systems is a good one as well. So that's like the key card or the badge swiping systems that unlock doors. Quite a bit of information about how the building is used in terms of occupancy comes out of that access control system. Also things like elevator control systems and other IoT sensor networks like occupancy sensors or people counting sensors. I don't know if you guys have done any research on this recently. I had no reason to do this when I was kind of in my old position, but they've got some really cool technology out there where you can mount a sensor on a ceiling. It's basically a sensor that's able to count how many people walk into and leave a particular space. So it's not just an occupancy sensor. Is it occupied or is it not? It's actually counting. There are 4 people in this conference room, or 3 people just entered the room and 1 person left. So those types of sensors and other technology systems give a really good look at things like occupancy, so how the building is actually, where people are actually going and how they're utilizing certain spaces. All of those roll up to what we call the live data systems. So those three main kinds of data sources, spatial data, asset data, and live data, are the three kinds of information that we tend to pull into a digital twin and normalize. We put them into context with one another, because they tend not to be within the same context. When you just pull up a Revit or a Navisworks model, you don't get the rest of this information. You just pull up the BMS, you don't necessarily get the rest of this information. Any questions about that so far? Was that pretty clear?
I think that was nice and clear. I like the way you laid it out. And just as a side note, the world of IoT is mind blowing. As the sensors get smaller and cheaper, it seems like there's no limit to what you can do with the Internet of Things.
You're absolutely right. And it's a point in time right now where a lot of building owners recognize that there's a lot of value there. And because it's still fairly new sensor technology and it's just getting to a point where it's financially viable, a lot of the companies that we're working with are doing pilot projects and proof of concept projects to do things like deploy occupancy and people counting sensors and figure out what do we do with this data. They know that they want to know where people are, but where the real value comes from is, well, when a lot of people are in a particular space, what does that mean for my heating and cooling system or my cleaning systems, right? Like a lot of times buildings are cleaned by a cleaning crew on a schedule. A person just kind of goes through, they follow their route, they'll clean every single conference room one after another. But if you've deployed occupancy sensors throughout your space and you have it in an environment where it's very easy to visualize where people are actually utilizing space, there's a strong likelihood that there are certain parts of the building. Maybe there's one elevator that 90% of the building tends to use. And that's the one that really needs to be focused on in terms of cleaning and sanitation. All the other 5 or 9 elevators in that elevator bay go largely unused, yet someone's probably still going to go and press the buttons to make it into every single one. So a lot of our customers are looking at occupancy as a way of getting a very good picture of how the spaces are used and how they need to be more targeted about the way that they do things like maintenance, cleaning, and other types of support that they offer. So maybe real quick before I jump into a demo here, I sort of alluded to this before when we were talking about the fault detection solution. One of the things that's different about the way Willow is approaching the digital twin solution as opposed to other digital twin providers in the market is that we're actually building out what we're calling the WillowTwin marketplace. And this works largely like the app store that you use to download apps to your phone, your tablet, or your device. So we talked about a lot of different systems that we tend to integrate to as part of setting up a digital twin, right? We'll integrate to the BMS, the electrical metering, access control, occupancy, things like that. And of course, there's now a lot of information within the digital twin after we've hooked up those different systems. But in the same way that you can go to the App Store and you can download an app that makes use of your camera, your GPS, your internet connection, all that kind of stuff, and create some sort of value or functionality for you. A lot of the technology solutions, like the fault detection providers that we talked about before, they want to be able to make use of the data that's flowing through the building. So we do the hard work of performing the integration of all those different systems. And then we put the fault detection solution or the analytics solution or other types of prop tech solutions on our marketplace. And we make it extremely easy for customers of Willow who have digital twins to simply download that app and install it on their twin. So just the right information that's already within the twin that needs to go out to the fault detection solution comes through our API. It goes into their environment. They start running their analytics, and then any insights that they produce or any faults or suggestions that they produce then get fed back into the twin and surfaced in our interface. Traditionally, the fault detection provider would need to maybe even come out to the building. They would need to coordinate a direct integration into the BMS to get all the data that they need. Then they would need to go and clean it up. So we're talking about several weeks of work and thousands of dollars worth of integration costs before they even start to generate any sort of value. But with a twin, if you already have all that data, it's already structured and normalized in a standardized way. We can do that just through the cloud. We bring that vendor in because they sit on our marketplace. You just install that app on your building, and they start to generate faults right away. So we're able to shorten the time to implement, reduce the cost, and this marketplace is growing and growing and growing based on what our customers are interested in feeding our data out to from their buildings in order to create more value for themselves and get an even better picture of how their buildings are being used.
Well, in that sense, what would you say is probably like the biggest, like, whoa, that you've seen, like a building or, owner, them come to you and be like, I can't believe that my building is being used this way, or in some scenario, like they're just like totally surprised, right?
That's a good question. To be completely honest, I'm not sure what feedback I'm allowed to share on. I've got a really cool story that I want to be able to tell, but I'm not sure if we're allowed to tell the story. One of the things that a customer that I'm personally working with, who's now just starting to deploy a whole bunch of occupancy sensors in their building. They've done quite a bit of research about like the pros and cons of each kind. And they're sharp enough to know that we're probably going to use this type of vendor in these situations. Like this vendor makes perfect sense in, I don't know, like elevator lobbies and amenity spaces. It's like, but for a lobby, we're not going to want to mount sensors throughout the ceilings that we've paid hundreds of thousands of dollars for. We're going to want to use our security camera footage as a way of being able to count the people that are walking through the lobby, and that way there's no we've got totally clean ceilings, keep our clean aesthetic, but we're still able to get that type of value. So they recognize that they're going to have different solutions to provide the same data about different parts of their building. So when they see something like Willow that is able to take those two different data sources, even though it's the same kind of data, it's just coming from two different places, they're particularly excited that, all right, cool, we can take my occupancy data, we can get a very granular picture of where people are going in the building, but I don't need to log into two different places just to see, all right, occupancy vendor A, here's where people tend to be, versus B. I can see it on a single screen. And then, of course, being able to put that into the context of things like, I don't know, heating and cooling and cleaning, it certainly helps them in that regard. So that's kind of a recent example of what's exciting to one of our customers.
Well, I'm sure it evolves also, right? Like as they get all this data, it's like, whoa, now I didn't even think about it. Now I can, have the cleaning crew come half the time, or, schedule the cleaning crew, have it a just in time kind of situation rather than anticipating, like that list is probably just ever growing.
It definitely is. It definitely is, because it's impossible to know, especially with a platform solution like this, right? So the Willow team, we're not trying to do everything. We're trying to build a platform or a framework that's going to be able to accept any kind of data that the owner and the customer wants, and help them make as much use as they can out of it. And because it's such a flexible solution like that, it's hard for us to be able to, we've got certain use cases that we're good at articulating, but it's impossible for us to tell a customer, hey, once you've got these types of systems hooked up, this is everything you're going to be able to do. Because you're absolutely right. They're going to start to see no two organizations are exactly the same. They all have slightly different business objectives and different strategies for being able to to serve their tenants or make money or operate their facilities. So you're right, the kind of different nuances that go into how they're going to go about their business and how they're going to operate has led to all kinds of different use cases that the Willow team, even when we showed up on day one, hadn't thought of.
That's pretty cool, and we're getting near the top of the hour here. So if you're able to show us a little bit of the magic behind the curtain, I think that'd be a great way to end up our episode.
Absolutely, yeah. What I'll show you a commercial office tower in Midtown Manhattan that we worked on with Brookfield Properties. This is One Manhattan West, which is one of several buildings on a broader mixed use complex. And what we've integrated to, you'll see in the demo here, we've got information on a little over 45,000 different pieces of equipment or devices or building components. There's live data, a little over 48,000 data points flowing through the platform in real time from systems like the BMS, the metering system, access control, elevator control, and we're serving this data out to a couple of different sources through our marketplace. So one is their work order and CMMS system, which is Angus Anywhere, which I realize probably doesn't hold a lot of meaning to most of the architects and the contractors that are listening. But the fault detection solution that we mentioned before is also at play here. It happens to be Copper Tree Analytics is analyzing that BMS and metering data. So without further ado, I'll jump out of PowerPoint and I'll pull up the platform. You guys still able to see my screen okay?
You bet.
Sure can.
Excellent. So this is the view that the Brookfield team has when they log into the Twin. And I should mention, this is a view that's developed for building operators and facility managers. There's a couple of things that we do that are specifically tailored to the way that they do their work. So first of all, this is just kind of like an abstract three-dimensional representation of the building. As I hover my mouse over, you can see each floor of the building is represented here. Some of them are highlighted in red or yellow. I guess we've got an orange one at the top here. And the reason we're seeing the different bands of color on this building dashboard is because there are pieces of equipment on those floors that have an insight associated to them. So if you think about what we were talking about before, where we've performed integration systems like the BMS and the fault detection solutions, those are reporting in real time, is there a piece of equipment that needs attention? And depending on what attention it needs, it might be an urgent level priority, it might be a lower priority. But the BMS, the fault detection solution, there's a variety of other solutions we've integrated to that are all producing these alarms that require someone's attention. So we're pulling all of those insights into a single list here, regardless of their source. So what an insight might look like, if I click on this one, an insight might say, like, this is an urgent level insight. This is related to a piece of equipment. It's an air handling unit on the fourth floor. Here's a little bit of information from the BMS about why that alert was triggered. We could see there's a history of work order tickets, because that's, of course, a big part of operating the building, is making sure you're tracking the time that you're spending resolving issues. So we can see there's 4 different work order tickets that are related to this insight alone. So this is a recurring problem that's occurring in the building. If we scroll down a little further, this is some of the BMS data that's relevant to this particular issue. So what's probably happening is this air temperature sensor that usually hangs out in like the high 60s, low 70s, plummeted down to 53 degrees at the moment this insight was triggered. So traditionally, this is an issue that maybe on the BMS, you would see this. You would see, okay, there's a problem. This piece of equipment is I don't know, it left a specific threshold or range. I better go look at it. But what we're pulling up here is in a totally different system. Here's the history of tickets that are related to this exact problem. So right there, those are 2 different systems that we've pulled together to go check, to go resolve this issue. If we click on investigate, it takes us directly to the piece of equipment in the building. So what we're now seeing is the 3D model viewer. You could see we're taken directly to the corner of the building where that exact piece of equipment is located. I'm going to pause for a second and show off the BIM. After all, this is a BIM podcast, so I want to make sure that we're highlighting the role that BIM plays in all of this.
Some sexy BIM right there.
It really is. This is the awesome work of SOM New York. They built the architectural model that you're seeing here. And then the MEPs are actually built by the trade contractors that purchased and installed all of this equipment at Manhattan West. So AECOM Tishman was the general contractor that coordinated the project. They've got a couple of really great trade contractors with good 3D modeling capabilities. So they did a full kind of BIM VDC coordination process for this building. And this is actually those models surviving into operations as opposed to collecting the digital dust that we talked about at the beginning of the episode here. So, of course, we're able to use the 3D model here. We were taken directly to this corner of the building, and the viewer highlighted the piece of equipment for us. What we're seeing on the right-hand side here is some of the asset data that we've collected. So we see things like this belongs to the mechanical system. We're seeing some temperature and air pressure information. We were talking before about attaching things like O&M manuals or submittals and cut sheets as part of the asset database. Like that's all right here. So if you're the engineer whose job it is to perform maintenance on this piece of equipment, or maybe you need to order a replacement part, you've got all that information right here at your fingertips from the contractor who purchased and installed this equipment as part of the submittal process. We talked a little bit about live data before. So we already saw a couple of BMS trend logs here. So here's the three that are most relevant to an air conditioning unit like this one. But if I pull down here, you can see there's a whole bunch of other types of data that we're able to pull up. And these are other data points on the BMS or the metering system or other types of systems that are relevant to this specific piece of equipment. So some of these fields might come from the electrical metering system, which would traditionally be a different login to a different platform and a different graph that you need to review. But here we're looking at that and BMS data and any other data sources that we want here on the same view. I mentioned before the relationships and how that's an important part of the digital twin as well. So what we're seeing here, this is just a list of the different relationships that are running in the background. And I'm happy to one of the things that we're actively developing are functionality that makes use of these relationships. So I know we were talking before about let's say you flip a breaker switch. What are all the different pieces of equipment that are affected? What are the spaces that are affected? Who are the tenants that take space in those spaces? This is just a quick list at the kind of relationships that are running in the background here. So things like, here's the electrical panel that serves power to this piece of equipment. Here's the steam PRV station that provides hot or heating and steam to this piece of equipment. Here's a damper that's upstream of it. It's located in this particular room in the which comes from the Revit model. So these are the types of relationships that are running in the background and are fueling some of the analytics that we were talking about. And we've got some really cool functionality coming down the pipe that's going to help visualize and act on those relationships pretty soon. So maybe we'll do another catch-up episode at some point in the future, and we could talk about how those are being used more effectively.
Well, and I think that's good fodder for the idea that we keep saying that all this data that we have, the owners don't necessarily need the model to pull forward. But as we start getting a platform like the Willow Twin, as we're looking at here, where we can take advantage of that model there's been a lot of time and effort and care put into create, and then we can tie it to that data that, sure, we don't need to see it visually, but now that we can, and as you can see, right now, for those of you who are listening, Ian's going through the model in the platform, and we can see all the bits and pieces. So not visual not required, but when it's available, it's definitely an asset. So we can get to that extra level of information. We can do measurements. We can walk around. We can turn bits and pieces on and off. Think of it like a Navisworks view. It's pretty awesome. And I think that as this technology grows, that's a great spot we can have you back to get more in depth into what's come of the platform and how much more it's being utilized. And I think just before we call it an episode, that one's for you, Bill. How can people get a hold of you, Ian, if they want to see, more than this little truncated version of what Willow can do for them?
Sure. You can find me on LinkedIn, or you could shoot me an email at isiegel@willowinc.com. Those are probably the best ways to get in touch. Awesome.
Well, thank you so much for your time today, Ian. It was very enlightening with great conversation. We lost Bill halfway through, but we'll get him back for the next episode, I promise. And with that in mind, for Dana, Bill, and myself, Ian, thanks a lot, and we will catch all of our great listeners on the flip side. Have a good one.
Thanks so much, everyone.
Thanks, Ian.